Simplifying rational expressions is all about factoring if you can, and then once it's factored, look to see if there's anything in the numerator that will cancel with the denominator. Our first example here, we want to look to see is there any factoring that you can do. So if you notice these other examples, has a minus, a plus, a plus, a plus, a minus, a minus. If you don't have any plus or minus signs in your rational expression, then there actually isn't any factoring that we can do. So we'll just simplify the expression as is. So this first example, if you notice, there's no plus or minus, so we're just going to simplify each thing that we have going on here. So first, you notice you have the 20 over the 4. So in that case, you actually will just take 20 and divide by 4. 20 divided by 4 is a 5. And then move on to your next set of bases. If you have an x squared over an x to the 5th, when you divide the same base, you keep the same base of x, but you are going to subtract those exponents. 2 minus 5 is a negative 3. So we've simplified the expression, but is this okay as a final answer? And you see that x to the negative 3, that's the thing that's not okay. You don't want to leave negative exponents, so this x to the negative 3 is going to move down here. The 5 stays on the top, and we have x cubed on the bottom. So if you don't have any factoring to do, just work through your expression left to right, simplifying each thing. Alright, I'm going to move down for this next example. Here we have plus or minus signs, so we're going to try to factor. We're going to rewrite it in factored form, and then we'll look to see how it simplifies. So that numerator, x plus 2, really can't do any factoring with an x plus 2, so that will stay as an x plus 2. The denominator is a trinomial, so when you have these trinomials, you want to look for factors of negative 10 that add up to a negative 3. So factors of negative 10 that add up to negative 3, negative 5 and positive 2 will work. So we have x minus 5 and x plus 2. Now that it's factored, we're going to look to see if there's anything we can cancel between the top and the bottom. And if you notice, this x plus 2 will cancel with this x plus 2. Just a reminder from what we've been saying in class, if you have any terms that are connected, that are with a plus or minus sign, for example, this x right here, it is connected to that 5 with a subtraction. I cannot cancel these out separate from each other. The x minus 5 can only cancel with an x minus 5. Once you get things factored and you actually do separate with multiplication like that, like there's multiplication right there, that's when you can break it off and cancel. Alright, so our final answer, when everything cancels from the top, we want to leave a 1 in its place. So we're going to have 1 over, and then the denominator, all we have left is the x minus 5. Alright, last example over here. Factor everything you can factor first. That x squared minus 9, that is our difference of squares pattern. So what do you square to get an x squared, and what do you square to get a 9? So it's going to be the x's and the 3's. So we're going to do x plus 3 and x minus 3. Remember, your difference of squares will have 1 plus and 1 minus for your factors. In the denominator, we have a trinomial, 3 terms, so factors of 3 that add up to a positive 4. And that's pretty straightforward, just x plus 3, x plus 1. 3 and 1 are the factors that work out. And now what we're going to do is we're going to look to see, is there anything in the top that you also see in the bottom that we can cancel? We see the x plus 3's, and that's actually all that we will be able to cancel. You have your x minus 3 on the top over an x plus 1. Now it's really tempting to see this x over this x and want to cancel those out. But if you remember, this x is tied to the 3 with subtraction. You cannot cancel those separate from each other. Again, this x is tied to the 1 with addition, so you can't cancel those separate. Because there's nothing else that will cancel, I have an x minus 3 on the top, but I don't have an x minus 3 on the bottom. That means nothing will cancel, and this is our final answer. So simplifying rational expressions, factor every single thing if you can before you see, and then you'll be able to see what might cancel between the numerator and the denominator.